Hi, in this video we shall see how to create a tab cell. We need to create a tab cell is because in the previous video we had seen how to create a layout for inverter using the standard cell approach. But here we don't have that body terminal connected to VDD or VSS. Body is for PFET is NMOS. NMOS is not connected to uh, VDD, right? So if you had remember the layout that we had created using layout Excel, using that method, you had that NVL tab and sub tab added here, right there, like this. That means the body is actually connected to VDD here and VSS here. The body is connected properly. But here we don't have that connection. Okay, this is called tabless library. So what we will be doing is we will create one more cell with only tab, and then whenever we want to run LVS, we instantiate that tab and then we will run LVS on it. Because if we run LVS on this, we won't get LVS clean because the body terminals of PFET and NFET are not connected to VDD and VSS respectively. We will get an error there. So for that reason, we need to add the tabs before running LVS. So first we will create the cell, new, click on. So it is called tab, small letter, keep the name tab. Why? Because tab is not a cell, so you will be having inverter, NAND, NOR, etc. Those are all functional gates actually. So tab is not doing any function other than connecting your body to your body terminal to respective VDD or VSS supply rails. Okay, so I am just keeping it as TAP small letter for that reason to differentiate between the actual gates and the non-gate cells. Press OK. Then what I will do is first I will in this tab I will be creating a tab cell uh, by taking this inverter as the reference. Okay, so what I will do is first I will just copy paste this like this. Delete, I will just close the inverter layout, maximize this, press F. Okay, so yeah, I have just copy pasted my inverter. Now what I will do is I will instantiate my inverter. Control F like this. And now what I will do is I have to create the NVL tab and sub tab uh, such that it is of exactly same height as the inverter. So I will just remove all the unwanted metal layers and connections. So this wires I don't want, these metal layers also I don't want, and I'll first keep my NVL tab for I just wanted to know what are all the layers are there, right? So for that reason I'll just keep my N tab and P tab or sub tab here. Okay, so now I will compare this. As you can see in P tab you have this uh, NSVT. We have NSVT here. This is actually PSVT, right? So you can just enable PSVT and see. So what I have to do is I will also delete. Okay, let it be now. So I will just move this here. Let me align it properly like this. Okay, and then uh, this is actually the PSVT of the instantiated PMOS. Okay, so I will flatten it out and remove this PSVT later, or else I will flatten it out now only. select the instance and then go to edit and then hierarchy and click on flatten. So select pixel, press OK. So I have flattened it. Uh, I will also flatten my Invert here that I had instantiated. Edit hierarchy and click on flatten. Then click OK. Like this. Press F. I don't want this via also. I will delete that via. Okay. Now what I will do is I will just enable again only PSVT and I will delete this PSVT. This fin area blue color line that is also not required. I'll delete that. The fin area of the Invert I will delete that also. Okay. Then what I have to do is I will enable only NSVT. Okay. So as you can see the NSVT should come here. Enable PR boundary and see if it is going outside or not. If it is going outside, then you should align it properly like this. So now this NSVT I will be deleting. Okay. So now we'll enable all the layers once again and then compare now. So next I don't want this active area, this thing to be there. Okay. So what I have to do is this LIACT I will just remove. I don't want this. Okay, I will also delete this and I will remove the texts as well. Okay, now I will color these metals. Press Q, all are metal ones only. Select all, make them mask to and lock it. Press OK. Now the next thing is what we have to do is we have to run DRC and see if it gives us any error, and depending upon that we will be adjusting these layers so that we will remove all the DRC errors. For that we need not use this as of now. We can just delete these things, and now I will be saving it and then running DRC. PVS run DRC. So I will be just running my DRC now. So yeah, we are having some errors here. So it says the NSVT PSVT is getting minimum NSVT to P active space is greater than or equal to 0.045. So what it is saying is, so I will just enable NSVT and P active space, right? So NSVT and P active space. So what it is saying is this NSVT is actually should be 0.045 away from the P active space. This is my P active space and this should be uh, actually should be away from that. P active space should be greater than or equal to 0.045. So I have to move this further left by 0.045 micrometer. Also it says NSVT is not allowed over P-type implant. So here NSVT and PSVT are overlapping. If you can see that. So here you can see PSVT and NSVT are overlapping here. Again here also they are overlapping. So what I will do is I will just close this, remove those errors, enable partial select, press yes, and keep it till this point. And now measure whether it is 0.045 or not. So this is more than 0.045, it is 0.065. So even NSVT should be away from the PA plus active space. That error is also removed. And here also we used to get one more error, that uh, PSVT should be away from the N plus active space by 0.045 nanometer. That error is also removed now. And also they are not overlapping now, right? So I will save it. Now I'll run DRC again. I can just open this and rerun here. I need not launch again. So now what it says, so minimum NSVT to P plus active space. Okay. So what it is saying is uh, NSVT to P plus active space. Okay, so this is saying this is N plus active space and it should be away from the P plus, this is my NSVT and this is my P plus active space. This should be away from this. Okay, what I can do is I can't stretch this inside like how I stretch the PSVT of my tap cell. This is my inverter, right? So I can't stretch that. I am not allowed to change, I am not allowed to touch any layers of the inverter. Remember, I have instantiated my inverter. That's why I'm not able to touch anything also, and I should not touch. Okay, so what I will do is I'll delete this part of the active area. Okay. Similarly, what I will do is same error is coming above, so I will delete this part of the active area. Okay, now if I open cut active, so I have this cut active here and I'll just move it such that it will be exactly on the poly. Enable poly and keep it exactly like here. We should avoid the formation of transistors, right? Unwanted transistors should not form. So similarly, I'll bring that, enable poly and move it like this. So now I have all the things done. I'll just make this cell also as mask 2, the via M1 to LICT via as mask 2. Lock it. Think I forgot to lock here. Okay, so press a save, then rerun DRC. So now what it says is you have your PSVT or okay, minimum NSVT spacing. Okay, so it is saying this NSVT and PSVT are overlapping like this. I will show it by just enabling NSVT and PSVT. So you can see there is this thing. So from NSVT to NSVT, the spacing should be 0.24 nanometer, right? So what I should do is just enable partial select again and then pull it till this point, exactly till where the error is gone. Now and do the same thing for uh, PSVT. Enable only PSVT, enable partial select, select the top edge and stretch it till this point. Press F2 to save and press F. Now again rerun DRC. So now you can see there are no DRC errors. So now you have successfully created all your uh, tab cell like this. So This is your tab cell. Okay, so what we will be doing next is this is my left tab cell. Okay, so now I will just keep these layers, okay, inside. I mean, what this is my left edge of the tab cell, right? So, for example, in your layout, you will be having your layout like this, right? All the cells will be there, adjusted, inverter, NAND, D flip-flop, everything. So you are having left tab cell here. So this should be your endpoint. The top level PR boundary will be coming like this. Okay, so there won't be any half DRC rule applicable here in this edge. So all layers should end here only. So for that reason, what I will do is I will enable, I will stretch these PR boundary to here. Instead of that, why I am not stretching this inside? Okay, let me see that now. What if I do that? Press F. Now save. Press F2. Now rerun. So you can see here this error you will get if you stretch it inside. Okay, minimum PSV to active area enclosure is 0.045 or 0.065. So what you have to do is you have to stretch it. Just measure 0.45 from here. Stretch this like this. Right, so just I will look at poly pitch. So now I will just rerun this. Yeah, I have successfully removed all the errors. Now I will press Shift K and press F2. Shift K to delete all the scales, and then I will delete this instance of the inverter, and I can actually uh, if you enable only NVL, there are like two NVLs, right? So I will delete one of the NVLs and then keep the NVL till only PR boundary like this. Press F. So now I will move this entirely to the left such that my layout is always in the first quadrant. Okay, so now actually I don't have the poly pitch lines. Uh, while copying, the poly pitch lines were not copied. So what I will do is I will just add the poly pitch line now. Carefully I should add now in such a way that my poly pitch line will coincide with this one and this one and this one. Okay, so first I'll start from here like this. So as I had mentioned you earlier, I don't want anything to be present here. So I won't be starting my poly pitch line here. It will be exactly starting from here. Okay, so you can see the poly pitch line. Okay, yeah. Now you can see the poly pitch line will be starting from here, and yeah. So this is how you create a tab cell left. Now you may also require the tab cell right. What if you may have to use the tab cell right? So how you will be creating is just this is exactly the same. This is the tab cell, right? Just close this. So if you go to tab, you have your layout as just rename it as layout underscore left. Press OK. Then open the layout. Before that, I'll just close my open the layout. Also, what we can do is this BDD VSS pins. Actually, we can add that here, or even if it is not added, it's not an issue. But um, later, that will actually, yeah. Okay, let us not add VDD VSS pins here. Okay, now save it as control. Press Control S, or okay, Control S is not working. Go to File and click on Save a Copy F3. Okay, then change it as layout underscore RIGHT. Okay, so now if you see here, you have your layout right. Now go there, layout right, and just invert it like this. Press F. So either you can do like this because this is just copying, but whatever you changes make in the layout underscore left won't appear here. You have to make those changes if in future if you are doing any such changes. So this is one method of creating layout, right? But what I recommend is I'll just delete this. Okay, instead I will just instantiate directly, hide, and then create it like this. Okay, instantiate it. Okay, then you rotate it and move it towards left like this. So now this is your layout underscore right. Done. Similarly, you need to create one more view called layout underscore mid. File, new, cell view, layout underscore mid. So here what you will do is where you instantiate first left. Okay, first you will instantiate right. Okay, like this. Then you will instantiate left such that your uh, this via will coincide. This via V0 or this LAST layer, this tab, actually this is the tab, right? So this will coincide like this. That way you will keep it. Now what you will do is you will just save it. So this is all about the uh, creation of tab cells. Okay, so one thing that what you have to do is you have to create PR boundary like this using this PR boundary object for all. For starting from inverter you need to create that. This is just a layer, so I had mentioned the same thing in the in creation of layout using that connectivity generate all from source. In that I had mentioned that you will be having two types of PR boundaries. One is layer and the other one is PR boundary objects, right? So in that way you need to create PR boundary, both the types of PR boundary. If you enable only PR boundary and see, and you can see here. Okay, so I will just select that and show it to you. Press Q. Now if you see here, you have that PR boundary. I'll just unselect these instances. So the pink color line, what you can see is the PR boundary object. Press OK. Then you can close this. So similarly for the inverter also you need to create that. Go to create P&R objects, P&R boundary. Start from here, then end it here. Press F. So then save it. Press F and close it. Similarly, for the tab left, you need to do that. Create P&R objects, P&R boundary. Press F and F2 to save it. Close it. And mid we have done. For right also we need to do. Create P&R objects, P&R boundary. Save. So that's all. So now the tab cell creation is done. That's all for this video. Thank you.